And if you have questions while I'm going through these, just stop me and let me know, or even ask it in the chat. I'm paying attention to that. So, all right. So for question 8, I believe this is the dopamine infusion question. I know there's, this is one of the practice tests, and there's 2 versions, but I think this is the one that you should be looking at. But basically, and I apologize if you can't see that. It's I can't get it to zoom in because the font's too small, but patients ordered dopamine to infuse at 5 micrograms per kilogram per minute. You have a patient weighing 70 kilograms, and the dopamine is available 400 milligrams per milliliter. And we want to know what rate should the nurse begin the infusion. And typically what they mean by that is how many milliliters per hour. So this is considered a complex question where there's multiple steps. We have to convert micrograms to milligrams, and we need to convert minutes to hours, and we need to account for the patient weight. So let's do that. Step 1, take the patient's weight and multiply it by the given of the 5 micrograms per kilogram per minute. Okay. When we do that, we'll get 350 micrograms per minute. Now, because my other, my available is the 400 milligrams per 250 ml, I know that I can't, I need to make sure that both these units are the same. So micrograms, milligrams, I can't do those. I can't compare those. It's like an apple and an orange. They both are fruit, but they're not the same type of fruit. So I need to get them and convert them. And so I'm going to do that by converting.
That's where I messed up at. I didn't change it.
So I'm going to go ahead and convert that. And I'm actually going to do 2 conversions here. I'm going to convert micrograms to milligrams, and I'm going to convert minutes to hours. So I'm just going to do that all in one step. Okay. Just because it'll give me a nice big number to work with, or bigger number if I keep it small. So we know that there's 1,000 micrograms in a milligram, and we know that there's 60 minutes in an hour. And so I'm just going to multiply across the top, divide by the bottom. I think I get 21, but let me just double check. 350 times 60 divided by 1,000. Yeah, 21. And then this will be 21 milligrams per hour. Okay. Oh, and then, yeah, this question. So this question is not, you haven't seen this one yet. This is something that was added in just as an extra challenge for you. I don't know. You saw something similar in 3rd semester, but this one's definitely more complex. All right. So now that I have the 21 milligrams per hour, now I can actually do something with the information, because remember, I want milliliters per hour. So what I'm going to do is I'm going to take my available, I'm going to take that 21 milligrams per hour, and I'm going to get rid of milligrams and convert that to milliliters. 400 milligrams, 250 milliliters. And when I do that, so 21 times 250 divided by 400. And you're going to get that, what the answer key says is 13.125 milliliters per hour. And then I'm going to advise you to go ahead and round that to 13.1 milliliters per hour.
Okay, because on the practice, it didn't say round.
Right. So, and that's my fault, because I created the test, I created the key, and for some reason I didn't round it, but you would round your answer to the nearest 10th.
And I know what I did. I just didn't
you didn't convert.
Yeah, but I don't, I don't like the way you do it. I do it the other way. So that's
fine. but as long as you know where you made the mistake, that's what's important. So like, yeah, you don't need to do it my way. You know, there's multiple ways to do this. So the reason I like to write this out is just so I can tell you and show you what I'm doing, as opposed to saying like, okay, I did 350, I converted at the 0.35, multiplied it by 60, got to 21. I like to at least show you that process. So,
Okay.
yeah.
I had a question about this question.
Yeah.
It didn't told us that is we need the milliliter per hour. How am I supposed to guess it?
So,
I think the question missing a sentence.
Yeah. Well, the question says, at what rate should the nurse begin the infusion? So anytime we have a rate, we already know, and like this is, you know, almost ingrained in you, is that we're talking about volume over time. So there's two rates that you are familiar with as nursing students. It's either going to be milliliters per hour or it's going to be drops per minute. Okay. And I agree with you. Like usually it will say like, what's the rate in milliliters per hour? The only reason I would say that you don't need to worry about drops per minute is because it doesn't give us doesn't say anything about microtubing. It doesn't say anything about calculating the drop rate, but the infusion rate is going to be the milliliters per hour. So you had to infer that that's what they were looking for. And I do believe this question looks like an ATI type of question. And so I imagine like on the ATI, you'll have some multiple choice, and the multiple choice will give you an option of milliliters per hour. And that's probably like how you could further decide like what to do with this problem. But this is what they wanted you to do.
ATI for pharmacology?
I have no idea. ATI for dosage calc is what I was assuming. Yeah. I don't know if you guys even do that anymore for beyond 110. So. All right, let's look at question 11. So question 11 is one of those questions that has extra information that you do not need in order to answer the question. Okay, so it tells us, you know, the patient's ordered medication at 200 milligrams IV daily. The available dose is 100 milligrams IV, and the label reads 30 milligrams per milliliter. How many milliliters of the drug will you give? So the extra information is that it's 100 milligram IV. Okay. What that is telling me is that there's 100 milligrams of furosemide in like 1,000-liter bag. And then, but what's important is every milliliter will give me 30 milligrams. So you're just going to take the 200 divided by 30, and that'll give you your milliliters of medication. All right. 16 also has extra information. And the reason I'm saying this is just because, you know, I'm looking at it and I know what's considered extra. The reason I know 16 has extra information is because if you've worked with me in the past, which I know a number of you have, you know that in order to calculate drop rate, you need two pieces of information. You need the flow rate and you need the drop factor. Okay. So do I care about the total? Only if it tells me I'm infusing 500 milliliters over so many hours, but it tells me the rate, 120 milliliters per hour. And then it tells me the drop factor, 15 drops per milliliter. So I'm going to take the 120 milliliters over 1 hour, which is 60 minutes, times the drop factor that they told me, which is 15. And I do understand that when I'm going through it, it's like, oh, that looks so easy. And it's because I work through these when I work with you guys, like I do this like multiple times throughout the day. And so it becomes secondhand. And so I try and slow down and show you where this information is coming from. But the reason I mention, oh, there's extra information is just to kind of help you to kind of figure out, okay, what do I need to know? Well, for flow rate, or I mean, for drop factor, I just need to know the flow rate in milliliters per hour and the drop factor. That there could be other information. I don't really care about that. I just need to know flow rate, drop factor. And this will give me 30 drops per minute. And then 17 is similar, right? So we have 180 milliliter unit packet of red blood cells within 1 hour, 10 drops per milliliter. So I'm going to do the same thing. Flow rate is going to be volume over time. So 180 milliliters over 1 hour times 10. So I'll write this over here. 180 milliliters over 1 hour, which is what? 60 minutes times my drop factor of 10. And I get, again, I think it's the same answer, 30 drops per minute. All right. So you guys did ask all the questions that have the extra information that you kind of don't need. 21. Yeah, your patient has received Solumedrol 200 milligrams IV. It is received from the pharmacy in a 120 milliliter bag of dextrose 5% water to infuse over 30 minutes. Drop factor is 10. No other IVs are running. What is the correct drops per minute? So again, what do I need in order to calculate drop rate? I need to know the flow rate and I need to know the drop factor. So we know the drop factor. That's pretty straightforward. How do I get the flow rate? Does 200 milligram IV tell me the flow rate? It does not. But the 120 milliliter infusing over 30 minutes, that tells me the flow rate. And so that's how you kind of weed out the information you don't need. The Solumedrol 200 milligram IV, that just tells you, like, if we were driving somewhere, this just tells you the car we're in. You know, am I in a Mazda? Am I in a Nissan? Am I in a Maserati? And then this just tells me the speed, and it's the speed that's important. So regardless of being in a Nissan or a Mazda, the speed limit is the speed limit. Okay. So don't get hung up on what it is. Get hung up on what you need, which is flow rate, drop factor. So that's actually going to be, well, it's similar. It's 120 milliliters, and this time 30 minutes times 10. And then when you do that, you get 40 drops per minute. I thought it was going to be 30 again, guys. So again, just pay attention to some of these that have extra information. You know, they want you to be able to kind of pick through some of that and make sure, you know, that you are able to differentiate the information you need. The other way that this might be written is you could have said, you know, you have a patient that's receiving Solumedrol 200 milligrams IV. It's received from the pharmacy in 120 milliliter bag, infusing over 30 minutes, but then it says how many milliliters would you administer if it was, you know, whatever milliliters per milligram. Then that would be another way that you might see this question oriented, and then you just want to kind of pick through that. But it wouldn't say anything about a drop factor if they wanted you to calculate milliliters. But if they want you to calculate a drop rate, they're always going to give you the drop factor. Hope that makes sense. All right, so 22 and 23 and 24 are basically warm up questions for the heparin protocol. It's basically just converting units per hour to milliliters per hour. So you see that it's every single time, that's what it is. So for 22, it says we have 750 units per hour. So let me get something to write that down. So 750 units per hour. Then it tells us that we have a solution strength of 25,000 units of heparin in a 1 liter bag. So 1 liter is the same thing as what? 1,000 milliliters. So if I'm looking for milliliters per hour, I want to convert units to milliliters. I have 25,000 units of heparin and I have 1,000 milliliters or 1 liter, and then we're just going to take the 750 times 1,000 and divide by 25,000. And then you'll get 30 milliliters per hour.
I forgot to change the measurement again. Oh Lord.
Okay. Or did you just leave your answer as 750?
I don't know. No, I didn't do 1,000 milliliter. I just did 1.
Oh, okay. Okay. So it was okay. So you got a pretty small number then.
Yeah.
Okay. Okay. All right. You're going to do the same thing for 23. You're going to set it up exactly the same way. Start with the 1,250 units per hour. Then multiply by the conversion from your IV. What does it say? It says 500 milliliters and then 25,000 units. 25,000, 500. You know, you set it up right. 1,250 times 500 divided by 25,000. And you get 25 milliliters per hour. So again, these are exactly what you're doing with the heparin protocol. When it asks you to calculate the flow rate, you took the patient's weight times kilograms, or patient's weight in kilograms, you multiplied it by the units per kilogram per hour, and then you converted units per hour to milliliters per hour. So this is the same process. That's why I say it's kind of like a warm up to the heparin. All right. And then the last one for your diabetic patient, they say 500 milliliters with 100 units regular insulin. It's infusing at 15 units per hour. Convert that to milliliters per hour. So I'm going to do the same thing. 15 units per hour. I don't want units. I want milliliters. What did it say? 500 milliliters and then 100 units. And then you're going to get 5 times 15, which would equal 75 milliliters per hour. If you need some additional practice, if you go into the OneDrive share folder, the 220, 230 additional practice problems, there's a few more problems that are similar to this. I think it's more flow rate, drop rate questions. So if you want some more flow rate, drop rate practice, those are some good ones to do. They're pretty straightforward. And then I've worked them out in the reviews, definitely in the 220, 230 reviews. But if you need to confirm your answers, just email me and I'll make sure you have that, because I don't think I have a key posted for that. All right. You're welcome. Heparin protocol. So what I'm going to do here for the heparin protocol is, I know you've worked through the 110 pound client multiple times. So what I'm going to do is I'm just going to give you an alternate scenario, and then we'll work through it together. So for the heparin protocol, what you need to remember, if it's been a little while, is just remember that the protocol is just what's boxed in here. There's 15 steps, and you're just picking out of the steps what you need to solve the problems that are down below. So for your test, you'll have 2 of these questions. So you'll either have A and B, or you'll have C1 and C2. Okay, so you'll have one of those 2 options. I've worked through this a number of times, so you've probably seen it a number of times. If you haven't looked at my YouTube channel, it's a good place to start. Step 2 of the protocol tells us the availables. So this is our IV, the 250 ml that has 25,000 units of heparin. And then our bolus dose is 1,000 units per milliliter. So I use the bolus dose strength to calculate bolus doses. And I use the IV to calculate my flow rate, my milliliters per hour. Step 10 tells us, and it repeats what's listed at the top, which is to bolus the patient with 80 units per kilogram, and then to start a drip rate at 18 units per kilogram per hour. That's good to know, because when it tells you to do different things down here, so if like it says to increase the rate by 4 units per kilogram per hour, we started at 18, we're going to increase by 4, so that'd be 22. Increase by 2, 20 units per kilogram per hour. Continue the current rate. If I'm going to decrease the rate by 2 units per kilogram per hour, then I'm going to drop that down to 16 units per kilogram per hour. And if I'm going to decrease the rate by 3 units, then it would be 15, right? Because 18 minus 3 is 15. For the bolus, it's either going to be 80 or it's going to be 40. Those are the 2 options for your bolus dosage strength. Okay. Keep in mind that you're going to convert the patient's weight in pounds to kilograms. If you have a long decimal, just round to the nearest 10th after you convert pounds to kilograms. So let's do a scenario that's different than what you have listed in your packet. So what I'm going to do is I'm going to give a different patient weight. We're going to do, let's just do 137 pounds. Okay. So a patient weighs 137 pounds. We want to convert that to kilograms. So 137 divided by 2.2 will give me 62.272727. So 62.3 kilograms. So for this scenario, I'm going to say that this person has already been, or this patient has already been on a heparin protocol, and we're going to check their APTT, and their APTT is 30 seconds. Okay. With an APTT of 30 seconds, we're going to look at the protocol, and you're going to see that in step 11, if the APTT is less than 35 seconds, then this is what we're going to do. We're going to rebolus with 80 units per kilogram, and then we're going to increase the rate by 4 units per kilogram per hour. So the 2 questions are, we're going to calculate the bolus in milliliters and calculate the NUR infusion rate in milliliters per hour. So those are the 2 questions we're going to try and answer, or we are going to answer. We're not going to try, we're going to do it. So step 1, 62.3 kilogram patient. And we need to calculate a rebolus. The rebolus is 80 units per kilogram. So I'm going to multiply by 80 units per kilogram. $62.3 times 80 will give me 4,984 units. Again, I don't want units, I want milliliters. So I need to convert units to milliliters. I'm going to do that using the protocol. And because we're calculating a bolus dose, I'm going to use the bolus dose strength of 1,000 units per milliliter. 1,000 units per milliliter. And I'm going to get 4.984 milliliters. Now, if I round this up, I'm going to get to 5 milliliters. So I know there's some discrepancy, but because it is already at 4.98, and if you were to round the 9 up, I'm going to go ahead and tell you that this would be 5 milliliters. I think that's a good safe assumption. I wouldn't tell you to leave it at 4.9. If it was 4.92, then leave it at 4.9, but go ahead and round that all the way up to 5 milliliters. So if you recall the answer for a 110-pound patient, it was 4 milliliter bolus dose. This is 5 milliliters, but that patient also weighs 27 pounds more. So does it make sense that you give them a little bit more of a bolus dose based off of their weight? And that's a rhetorical question, right? So hopefully that means yes. All right, what's the new infusion rate? So same patient. Now, what was our initial infusion rate? Our initial infusion rate was 18 units per kilogram per hour. So that was our starting point, but we're not doing that anymore. We are now increasing the rate by 4 units per kilogram per hour. So what was the original? 18 increased now by 4. So 18 plus 4 is 22. 22 units. So I'm going to take 62.3 times 22, and I'm going to get 1,370.6 units per hour. So I don't want units per hour, I want milliliters per hour. In order to figure out that, as a reminder, I'm going to go back to step 2 of the protocol. Step 2 of the protocol has 2 available things. It has the IV and it has the bolus dose. We're not calculating a bolus dose, so I'm just going to ignore that for this point. What I'm looking at though is that 25,000 units in 250 milliliters. That I do want to know about. Okay. So 25,000 units, 250 milliliters. And just as a reminder, if you don't recall, this is the same thing as 1/100. It's always the same, at least, I mean, for the heparin protocol, it's always the same. So I'm going to take that 1370.6 divided by 100, and I'm going to get 13.706 milliliters per hour. And you can just round that or simplify that to 13.7 milliliters per hour. So again, with the heparin protocol, it's just, you guys have done this, you did it last semester. You've practiced these. The thing that can change on your test is the patient's weight. And now you've seen if we used a different APTT, you know what to do. It's just a matter of practicing it. You have any other questions for the practice test or the fourth semester test?
Yes, question number 6. I'm getting the right answer, but I kind of not understand what I'm doing. I do this because I know math.
Yeah.
But
Well, tell me what you're doing with number 6.
I think I did 600 times 40 divided by 150.
Sorry, hold on. I had the wrong test. Oh, okay. You did 600 times 40 divided by, or I'm sorry. Yeah, you did 600 times 40 divided by 150.
I think it's what I did, yes.
Okay.
But I want someone going like behind what I did.
Sure. No, and you're absolutely right. So let me show you what I've done for like questions like that. So I have like a little bit of a formula that you can follow for your intake output questions. You're going to take your actual output, so what the patient actually voided. You're going to put that over what I call the theoretical output, which is that, you know, for every whatever milliliters out, replace, and then multiply that by the replacement volume. And that will give you how much to do. So the actual output for this question was 600 milliliters. The theoretical output was the 150 milliliters. And then a replacement volume was 40 milliliters. So what you did was exactly right. Where this came from, since you asked about having like some sort of a backup, is this is just reorienting the question that was basically a ratio proportion question, meaning if you take 40 milliliters over 150 milliliters, which basically just means like this is for every 150 milliliters lost, you're replacing with 40 milliliters. That's equal to how much was lost. And then you're trying to figure this out. And so if you rearrange this, you bring that 600 over here, you get this setup.
Yeah, this is what I did.
Yep.
Like,
so you did that 100% correct. If you do that, if you do this every single time, you'll get it right every single time. If you do it this way, you'll also get it right. Just keep in mind that it's not always the biggest number that goes up here. It's the actual output that goes here. So this number could actually be less than the 150, and you could still calculate a replacement volume. It would just be a number less than 40.